Hello, friends. This is part 2 of longitudes and latitudes. The topic we began in part 1, and I did promise that part 2, 3, 4, and 5 we are going to release weight solely on past questions, and that's what we are going to do. So let's jump right into it. All right. The first question here says 2 points x, um, 32 degrees south, that's latitude, long 86 degrees west, and point y, 32 degrees south and 14 degrees west, the long, are on the Earth's surface. Calculate correct to 3 significant figures. The A, length of chord, x, y. All right. Now, of course, the first thing to do is to draw the Earth as usual. I'm going to make it to be much bigger, like this. Aha. Okay. So here is our north, south, east, and of course west. Now, this is our equator and our prime meridian. Okay. Now let's plot the first point. The first point here, first point here, we have 32 degrees south. That's the latitude. So somewhere here, 32 degrees south. Remember, you write latitude by the side, whereas you use your arrow to indicate the value of the longitude. We had said that before. Okay, you can make this into a circle, a small circle. Okay, that's the lat. Then the long, this one, 86 degrees west. So let me use white. Eighty-six degrees west. Okay, so the point of intersection, that is this point, will now be our what? X. This is our X. All right. Point Y, 32 degrees south, is the same, so you don't need to redraw it. And the longitude is 14 degrees west. Okay, so 14 degrees west. We make it this way, 14 degrees west. Okay, so this is 14 degrees west. All right, so the point of intersection, again, that's here, is our y. So this is our y. Okay, so here is the center of the circle. The center of the circle is this point here, so we can connect this to this. So the angular difference is here, and which should be our theta. So theta, angular difference, should be what? Now again, let me mention it. I had said that before. If the two longitudes are on the same sides, in this case, can you see on the same side of the prime meridian? This is the prime meridian. Okay, and the two of them are on the same side. That means you subtract. So this is going to be 86 minus 14, and that gives us what? 72 degrees. So this is our angular difference, our theta. All right, so the question now says we should find the length of the chord. So if I'm to redraw this, let me draw a circle like this. This is the center of this circle. All right, then we have here is our x, and here is our, let's say, y. Okay, they are not asking us to find the length of the arc. They're asking us to find this chord. Let me use a different color. They're asking us to find this chord. All right, x, y. Okay, so what are we going to do? The formula for calculating the length of a chord is 2r sine theta over 2. All right, you want to derive this. Okay, let me quickly show you how you can derive it easily. Remember that this angle here, of course, is 72 degrees. Okay, just in case you want to know why the length of a chord is 2r sine theta over 2, if we have a circle like this, I'm going to be very fast because I need to show you how to remember this. Okay, this is our x and this is our y. Now the theta here, if I okay, let me use the chord is this is the length of the chord xy that we want to find. If I bisect this, I'll be having theta here will be theta over 2. All right, so remember that this triangle is an isosceles triangle, so r here, that means the two sides are equal. So let's imagine that here, this side from x to this midpoint, this is the midpoint. From x to this midpoint, let's call it something like a. Okay, x to midpoint. Okay, so of course this triangle will look like this. Okay, to look like this, theta over 2, then a, and then r. All right, so if you put your SOHCAHTOA to use, this will be sine opposite over hypotenuse. So sine theta over 2 will be opposite, that's a over r. So if we cross multiply, we get that a will be equal to r sine theta over 2. All right, but the length of the chord is not just a, it's a times 2. That is from here to here. So we're going to multiply this a by 2. Therefore, our length of the chord xy will give us 2r sine theta over 2. So that's how to derive it. Now this is what we are going to be using to answer this question number A. All right, so let's plug in the values. Length of the chord, chord xy, that's 2r sine theta over 2. But remember that r is capital R cos alpha. So I'm going to rewrite it like this. This is 2 times capital R cos alpha times sine theta over 2. Okay, so if our alpha is 32 degrees, you remember, and theta is 72 degrees. So can we now plug in the values? The length that we're looking for is now 2 times 6400 times cos 32 times sine 72 divided by 2, which is 36. All right, so if we punch this well, that's 2 times 6400 times cos 32 times sine 36. It should give us 6380 kilometers. All right, that's to 3 significant figures. This is the answer. Okay, B says distance between x and y along the parallel of latitude. So this is let's label properly. This is question 1bi. All right, now the question says we should find the distance between x and y along the parallel of latitude. That's small circle. All right, so again we had this our circle like this, and this is the center of the circle. Here is x, y. We had already found the length of the chord like this because the angle 72 degrees. Okay, now we want to find the length of the arc xy. We had found length of the chord. The arc is now like this line here. That's the arc. That's what we want to find. And then the formula for calculating the length of the minor arc is, so I'm going to say xy is equal to theta over 360 degrees times 2 pi. Is it going to be small r or capital R? Remember, we are still dealing with small circle. Remember, the question says parallel of latitude, small circle, so small r. All right, so let's plug in the values we have. Theta is 72 over 360 degrees times 2 times 3.142. We're asked to use pi as 3.142, then times our r is capital R. Remember, small r is capital R cos alpha, and of course that will now be 72 over 360 degrees times 2 times 3.142 times 6400 times cos 32 degrees. Now if you punch this well, you are supposed to get 6820 kilometers, and that's the answer. All right, kilometers. That's to three significant figures. Okay. All right, so number 1bii, question 1bii now says we should find the distance between x and y along the great circle. So what are we going to do now? Let me turn to a fresh slate again. This is question 1bii. All right, okay, so we are asked to find the distance between x and y along the great circle. So what are we going to do? Again, let me draw the circle we had before. We had this circle, pardon, this circle that I've drawn is chamferedly orchestrated, but it's okay. This is x, this is y. All right, and here is our theta. Okay, now I'm going to draw another arc like this. Let me use a different color. Draw another arc like this, but I'll make it into a much bigger circle like this. Okay, now this is the distance, this is the great circle. Okay, and I'm going to trace like this. Okay, so this is capital R, this is capital R, this one is small r, this is small r. Okay, now let me do this. This angle here is theta. Let's call this angle here beta. Okay, just for the sake of clarity, beta. Okay, now we have found the distance xy along this small circle. All right, this is the distance along the small circle, the parallel of latitude. We now want to find it along this. Hope you can see the white along this. That's the great circle. Okay, so what do we do? There's a formula you need to take note of. We have sine beta over 2 is equal to sine theta over 2 cos alpha. All right, this is the formula that can aid you to find the beta, because once we find this angle, all right, then we can find the distance along the great circle. Okay, so again, you can make the beta the subject of the formula, and that gives you 2 sine inverse of sine theta over 2 cos alpha, like this. Okay, so with this now we can find the angle, and after that we now find the distance along the great circle. Okay, so plug in the values. We have what? We have 2 times sine inverse. We have sine theta is 72 divided by 2 is 36 degrees. Then cos alpha is 32, like this. So if you punch well, you're supposed to get, okay, you're supposed to get punch. Good. Okay, so we get 59 point, approximately 59.8 degrees. So that is the beta. Okay, so we can now plug in the length, which we are looking for now, the distance between x and y along great circle. XY along great circle will now be what? That's beta over 360 times 2 pi capital R. Okay, that's 2 pi capital R. The angle will now be beta, not clean this, it looks dirty. Okay, so the angle will be beta here, this angle that we have found. So let's go ahead and plug it in. Okay, so along great circle is xy along great circle will be equal to, that's beta over 360 times 2 pi capital R. All right, remember we are dealing with great circle, so this R has to be capital R. So if we plug in the values, we have our beta is already 59.8 approximately, all over 360 degrees times 2 times 3.142 times 6400. If you punch this well, it should give you 6680 kilometers, and that should be the answer. 6680, look at it here. Okay, so that's the answer. So it's as simple as that. Now let's take the next question here. All right, so question number 2 says P and Q are 2 points on latitudes 50 degrees north. Their longitudes are 40 degrees west and 140 degrees east, respectively. Find the distance from P to Q. Excuse me. Okay. Now, you can pause the video and give this a trial. After that, you can continue. So, solution. Again, don't forget, the first thing to do is to draw our circle. So I'm going to draw, let me make it bigger here. Okay, so these are circle again, the equator, and then the prime meridian. Okay, here is our north, south, east, and west. All right, so point P and Q are 2 points on latitude, sorry, not latitude, latitude 50 degrees north. Okay, so this should be our 50 degrees north. So you just draw by inspection, something like this. Okay, this is our 50 degrees north. Okay, now their longitudes are 40 degrees west. 40 degrees west. Let me use this 40 degrees west. Okay, 40 degrees west. All right, and 140 degrees east. 140 degrees east. 140 degrees east. 140 degrees east. Okay, so where are the 2 points? These are the 2 points. Is why the 2 points. The first one is P. They say respectively, so you have to go based on the one that comes first. That's P here, and then here is Q. Is Q. If this is the center of this small circle, okay, now if we draw like this, take a look at something. The angular difference will be what? Look at this is 40 and this is 140 degrees. The angular difference is going to be sum, right? Since the two of them are on the different sides of the prime meridian. All right, the prime meridian, the central one. So if we add the two of them, we'll get 180. So what do you think? Listen, anytime the angular difference is 180, it means that this Q here lies on the same great circle, on the same meridian. Okay, it's just like this. Oh, wish I could draw. It's like this, and then this other side. This is a great circle. That's this longitude 40 degrees west. All right, now if you have, that means this is the latitude. This one is here, P is here, and Q is on this other side here. This is Q. So this has to be a straight line, just like the diameter. All right, if you have a circle like this, okay, and as long as it's an obtuse angle, okay, let's say acute angle between 0 and 90, it's okay. Obtuse angle between 0 and or between 90 and 180, it's okay. But the moment it becomes a diameter, that means 180 degrees. The angle here is 180 degrees. Can you see that? It means it's a straight line. Please always be on the watch out for angular differences that will sum up to 180 degrees. Very, very important. So I can erase this now and put this Q here. This Q will now be here. Can you see? It's a straight line like this. Okay, now that you've got this, our job now becomes easier. Okay, so anytime please always be on the watch out for this. So anytime the angular difference is 180, the implication, if the angular difference theta, if theta is equal to 180 degrees, the implication, the first implication is that the 2 points lie on the same great circle, okay, which passes through the north, the north. Okay, so watch here. I'm going to let me use a different color, through the north. So see, the distance we are looking for is from this point P to the north, and then from here back to this point. Can you see? Let me mark it again. From here to the north, like this. All right. Okay, so another implication, number 2 implication, all right, is that your beta now, beta will be 180 minus 180 minus, so 180 minus, let me make it easier for you, 2 times the lat, whatever the latitude is. Use this formula to get your beta. Or I can do this. Let me show you another way. Let me show you a much better way. If I have my circle like this, let me just redraw what I had drawn before. This is prime meridian. This is our lat, is lat 50 degrees north. Okay, so this point is north, south, don't forget, east, and west. Okay, make this into a circle. Now look at the 2 points we are dealing with. The 2 points, this one here is our P, and this one here, oh, this not here, here. Remember, the sum is 180, so it has to be on a straight line. It has to be on a straight line like this, on a straight line like this. Okay, so we now want to find our beta. Remember, this has to do with the great circle. Okay, our beta, you remember the angle beta, we saw that the previous question. So the distance we actually want to find is the distance passing through the north, that is from here to the north, and then from here to here. Okay, so now if this angle, remember this angle from here to here is already 50 degrees. So let me draw something like this. Kai, I just wish I could make this very snappy. It's like this. Here is north, here is south. Okay, and then we have this. Okay, so this to here, remember this is the latitude already, 50 degrees north. So this angle to here, I can make something like this. To here is already 50 degrees. To here, this other side is already 50 degrees. Okay, so this angle now from here, from this point to this point, let me use white. From this point now to this point will be what? What is remaining? That's 40 degrees. 40 degrees. Then from this point, again, from this point to this point is now 40 degrees. So that means that the angle that I'm looking for, the angle will be what? This angle here, which I'm to use to find this, the distance here, will be 80 degrees. That's another way. That's if you don't want to use the beta is equal to 180 minus 2 times your lat. Okay, that's the formula. This can help you get it easily. All right, you can as well look at this diagram that I've drawn above here. Okay, I don't want us to waste much time on this. Now, having said this, let's now go ahead and find our beta will be what? Our beta is 180 degrees, 2 times the lat is 50, which is 100, times the lat, which is 50. That gives us, well, 180 minus 100 will give us 80 degrees. That's our beta. But don't forget that our theta is what? Our theta is what? What's our theta? Our theta is still the angular difference. That's 180 degrees. 40 degrees west plus 140 degrees east. That's 180 degrees. Okay, so we are now going to use this to find the distance along the great circle. Okay. So along the great circle, distance PQ along the great circle is theta over 360 times 2 pi capital R. Don't forget. Okay, and our theta is remember, along the great circle you use beta, not theta. All right, so we are using beta over 360 times 2 pi capital R. Oh, it's okay. So beta, our beta is 80 degrees. 80 over 360 times 2 times 3.142 times 6400. Okay, so if you punch this well, you are supposed to get 8919 kilometers. All right, which is 8920 to three significant figures. All right, so we have found this. Now to find B, 2B now says we should find along a parallel of latitude, that is lat 50 degrees. Very simple. So PQ, again along small circle, is equal to theta over 360 times 2 pi small r. Don't forget. Okay, so let's plug in the values we have. Theta is 180 degrees. That's the angular difference over 360 times why am I writing these times here? Times 2 times 3.142 times capital R, that's 6400, times cos. Do you remember? Cos alpha, which is cos 50. Okay, so if you punch this well, you are supposed to get 12,929.46 kilometers, and that becomes the answer. All right. Oh, I don't want this video to be too long, but it's okay. So here are your assignments. All right, solve these two questions, number 3 and number 4, and we shall continue in part 3. All right, I will give you a detailed solution to the 2 questions in part 3. All right, so thanks for watching and see you in part 3. Bye bye.